Welcome back to Moral's Math Corner. We're going to talk about sine, cosine, and tangent graphs today. And I don't want you to stress out about these function graphs because they're actually really easy. I'm going to first start out by teaching you guys about the sine and the cosine. I'm going to show you that the sine and the cosine are pretty much identical. The only difference is their starting points, okay? And the reason that their starting points are a little bit different is because if you remember, the sine and the cosine are cofunctions. So every point on the sine will have a matching point on the cosine off by 90 minus theta degrees. So the value of the sine of 30 on the graph is going to be the same as the value of the cosine of 60 on its graph. So that's why they're so very similar. Let's talk about what these letters mean. First of all, A. The A stands for amplitude. Okay? The amplitude means how high, which is called the peak, or how low, which is called the trough, kind of like sound waves or real ocean waves. Okay, there's a peak and a trough. The amplitude determines how high or how low it goes, or rather how high and how low it goes. So in this particular case, if this graph that we're seeing here is just basically sine of x, so there's an invisible 1 as the coefficient in front of the sine. So that is why my peak is up here at 1. And my trough is down here at -1. Now, the amplitude goes up and down from what's called a baseline. At this particular stage in the game, the baseline is the x-axis. Okay? Tomorrow, we're going to go ahead and shift these graphs horizontally and vertically. And there's going to be another letter that I'm going to add on to this called the C, and that will determine the new baseline. But for right now, when I have my function of the sine in this form right here, I'm not adding anything to it, okay? My baseline is x. Yes?
Could you ever have like a peak of 2 and a trough of 1?
Okay, the question was, could you ever have a peak of, let's say, 2 up here and then a trough of 1? No, that will not happen. The sine graph is similar to a sound graph. Okay, it's constant. Its amplitude, once it has an amplitude, it's going to have the same amplitude while it's going up and down. It's not going to deviate. Thank you. That's a good question. Now the B. The B I have in red, it's over here, okay? The B determines the period. What's a period, Mr. Morrow? Well, a period is one complete full cycle of the graph, okay? It's one complete full cycle of the graph. For sine and for cosine, just so you know, the period of the sine or the cosine is 360 degrees. So that means that once the sine graph completes one full cycle, the span of that cycle was 360 degrees. That's what the period is. But the B is going to help determine the period. The full entire length is going to be 360 degrees. But it does not necessarily have to go from 0 to 360. You could have a sine graph, for example, that started at -180, ended at 180, and you have your little sine graph. Isn't the distance from start to finish here still 360 degrees? So the period will always be 360 degrees. What's going to differ here is the starting and the ending points. All right? So with your B, you're going to find the period, which is going to be 2 pi, or 360, 2 pi's in radians, 360 of course in degrees, divided by B. And that is going to give you your period. Okay? Now, your end point and your starting point is going to be right there. Now, the intervals. There are key points that the sine graph must go through. And you find these key points by taking the value of the period and dividing it by 4. And when you have those intervals, you're going to have 4 intervals, it's going to work out like this. Baseline, peak. Baseline, trough. Baseline. I'm going to show you, of course, with numbers how all of this works. But I wanted to first introduce what the graph looked like, how to find the amplitude, the period, the intervals, and then how to graph it out. Does that make sense? Yeah? Any questions before we move on to the cosine? I'm just being patient. Make sure you guys get this. I'm sorry, sir? Okay, the question was, is x the angle? Yes, very good, son. Vx is the angle. It's the theta. Yes, sir. Yes, sir. 100%. Thank you. Yes, sir. When you find that, what? What's the that? Well, you're never really finding the x here, my man. You're gonna no. The x is a degree that I can plug in. So once I have my whole entire graph, I can plug in different values of x or degrees, and you can match them up to the y value on the graph. Let me graph them with real numbers, and then I'll show you how to plug in the x. But no, we're not really finding the x. The x can be anything. The x can be anything. It's independent. Okay? Okay, the question was, do I keep it in degrees or radians? It's really going to depend on you, sir. I'm going to show you today how it works with both radians and degrees. If you want to stick to degrees, make sure if you ever see radians, turn it into degrees and vice versa. Okay? Yes, sir. Correct. The question was, where it says here, y equals a times the sine of bx. He's asking, is b the actual angle? No, it's x. X is the angle. B is just going to determine the period of this graph. But the angle itself is the x. Yes, sir. Yes, sir. No, B does not equal 360. The period equals 360. B is going to determine your period. You're going to take 2 pi and divide it by the B, which is going to determine your period. Or 360 divided by the B. No, I never said it was. B determines the period. But the period of a sine and cosine is 360. Why do I have to determine it by, why do I have to divide it by B? Because that little example that I told you over here. If your endpoints ended up being negative 180, okay, and 180, when I make this sine graph, is my period not 360? Right? From starting point to end point is 360 degrees. Where it is on the graph, that's what the B helps determine. Does it make sense, son? I appreciate your question. Thank you so much. Anything else so far? We're good? Okay. Let me show you cosine right quick. Cosine, you may look at this and go, oh my God, I have to write all of this again. No, you don't. I just did just to show you what the cosine is, but it's all the same, guys. I promise. Altitude, that determines how high, in this case right here, and how low it goes. Same thing. The B, The B determines the period. It is not the period. The B determines the period. So in this case, just like the sine, the cosine's period is also 360. Where that 360 interval is going to occur depends on the B. Remember, guys, I can go from negative 90 to 270. That's still 360 degrees. I could go from negative 360 to 0. That's still 360 degrees. Okay? The period doesn't change. It's the location of the period. And the location of the period is determined by the B, 2 pi over B or 360 over B. Intervals for the cosine, same thing. Intervals determine the key points on the graph or of the graph, and it's the intervals equals period divided by 4. Does that make sense so far? Same as the sine, right? And then when you're graphing your cosine graph, there's a little bit of a different pattern. Remember that the sine was baseline peak, baseline trough, baseline. This guy's a little bit different. Cosine is peak, baseline, trough, baseline, peak. Yes, sir. The pattern does not change for the sine or the cosine ever. Yes, sir. Thank you. Great question, son. Good question. Does that make sense so far? I'm going to go ahead and do an example or two, depending on how much time we have before we break. And then when we come back from the break, we'll do our tangent. Okay? May I continue, gentlemen? Okay. You okay? Have a little wait. No worries. Oh, thank you. All right. Okay. Let's do this. Oh, sorry about that. Boo. Hold on. Let's go back. Boo. Okay, well, it's ruined. Okay. Sorry about that. I wanted to be sophisticated, but I messed up. All right. We got y equals 2 times the sine of x. Let's graph this sucker. First of all, we got the amplitude equals 2. So what I'm going to do is you can label your graphs pretty much how you want. You just have to stay consistent. So for example, I'm going to break this up into quarters. So that's 1, and that's 2. And then I've got 1, 2, 3. That's negative 1, 2, 3, and that's negative 2. So I'm setting up my graph because I know that I'm going to go as high as the 2 and as low as the negative 2. In this particular case, my period is 2 pi over b. The b is 1 in this particular case, so my period is 360 degrees, or 2 pi. Okay, so you start at 0. Yes, sir. Yes, sir. X, okay, for the 4th time, is the actual angle. Okay, thank you, sir. Now, number 3. Intervals. Your intervals are going to be the pi, the 2 pi, the period, divided by 4. Or 360 divided by 4. So your intervals are going to be 90. Okay? So now, let's set up our intervals before we graph it. I'm going to say that every 2 units on my graph here is 90 degrees. You can make it however you want. I don't care, as long as they are consistent. Don't tell me 2 units are 90, but then 4 more units is another 90. Stay consistent. So, 2 units, we got 90 or pi over 2. You got to know how to toggle between radians and degrees, because on tests like the SAT and the ACT and my tests, and in pre-calculus and calculus, you're going to have a lot of radians. They kind of tend to leave the degrees behind. Okay, so start getting used to radians. Another 90 is 180 or pi. Another 90 is 270 or 3 pi over 2. Thank you. And another 90 is 360 or 2 pi. Now, I'm done. Now it's the easy part. Okay? My period here is 360. So I'm starting at the 0, and you go baseline, peak, at my next interval, next 90 interval, baseline, next 90 interval, trough, next 90 interval, baseline, and you have a beautiful sine graph. Now, sine graphs, like sound waves, continue forever. So unfortunately, I am sorry, but you've got to go backwards one cycle. I need 2 periods for a proper graph. So easy. This would be negative 90. This would be negative 180. This would be negative 270. This would be negative 360. We got to follow the same rhythm, so you're going to have to go backwards now. You go trough, base, peak, baseline. And then, if you look at the whole cycle from start to finish, we have the continuous pattern. Baseline, peak, baseline, trough, baseline, peak, baseline, trough, baseline, etc., 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 continues forever. Does that make sense? Yes, sir.
Now on, we're going to always want two periods, right?
Yes, sir, please. Whenever you graph these, I need 2 periods, please. Thank you, sir. Okay? Now, cosine graph. Let's run through this right quick. The amplitude is 3. So I'm going to go this time. I'm going to go, that's 1, that's 2, that's 3. It's negative 1, it's negative 2, that's negative 3. Next thing I'm going to check out is my period. This time, I might have a b that's 2. So my period is 2 pi divided by 2, which equals pi, or 360 divided by 2, which is 180. That's my period. Okay? Now that period, I got to cut up into 4 to get my intervals. Okay? So my intervals here are going to be 45 degrees. So I'm going to go every 2. 45, 135. I'm sorry. Thank you, son. Good catch. 45, 90, 135, 180. Thank you very much, son. As far as radians go, pi over 4, pi over 2, 3 pi over 4, and pi. You're done at this point. If you set everything up like I'm teaching you, you're done. Now, it's the cosine. Peak, next interval, baseline. Next interval, trough. Next interval, baseline. Next interval, peak. We got to go backwards. Negative 45, negative 90, negative 135, negative 180. So we're dropping down to baseline, trough, baseline, peak. At the end, it follows the pattern of peak, baseline, trough, baseline, peak, baseline, trough, baseline, peak. When we get back, we will knock out the tangent. Thank you. Okay, so that is how you graph a cosine function. Now, I do want to explain to you that you can have a positive or negative sine or cosine function, and the A will determine that, okay? If the A is positive, then you're going to have a positive sine graph, of course, and a positive cosine. If A is negative, you're going to have a negative. Let me show you just the sketches of those so you can understand how that works. If I have y equals positive A times the sine of x, we're looking at a graph pretend that the b is 1 and that point's there, right? If there's no b, it's going to go like that. If it's negative, though, we'll do it in red. If it's negative, we've got y equals negative a sine of x. The sketch of the graph is going to look like that. So if it's exactly, it's just the opposite. If it's positive, I'm going up to my first interval. If it's negative, I go down to my first interval. Okay? Same thing for the cosine. If I have y equals positive a times the cosine of x, I'm looking more or less at that form. If I have y equals negative a times the cosine of x, it's exactly the opposite in this case. So now I'm going to start down and I'll go up. Okay? So that's the difference between the positive and the negative. Everything else is the same. Everything is the same. The only difference is that the positive is going to start going up and the negative goes down. Yes, sir?
So I'm guessing like this would be the same, but it's reciprocated if it was a secant and cosine, right?
Your thinking is very good. The question was, this would just be reciprocated if you had the cosine or the cosecant. Similar, but not exactly. We'll get to that tomorrow.
So we're not gonna have
Okay? No, today we're just doing sine, cosine, and tangent. Thank you, son. Now, the tangent. The tangent is the bad boy, all right? This is the one that kills a lot of people. This is the one that is very rarely taught well in books. I really don't like the way they do it. Again, this is just accumulation of different things that I have seen through my life, different books, different tutorial videos, and I compiled this into a fashion where I think it's very simple for everybody. Now, amplitude, A. Well, let's reverse. Why do I have both of these? This is the standard. This is just the basic. This is translated. We're going to learn about translated sines and cosines and tangents tomorrow. Why am I adding it today? Because I'm going to teach it with the most difficult type, and that's going to make it easier for the easy type. Okay, so trust me. This C here, we're going to ignore this today. Please don't think that I forgot or that I didn't do the right thing, I messed you up. No, I promise you. This C is simply going to change my baseline. Remember how I said right now the baseline is x. When I add a constant to this function value, that's going to change the baseline. But we're not going to worry about that today. But I didn't want to not explain this to you, and then you get confused and you say, what is this guy doing? Okay? So, A, the amplitude. There really technically is no amplitude here. All right? Because the tangent and the cotangent, you'll find out tomorrow, goes on forever. Okay? This little green graph is going on up and down forever. There is no amplitude. I am going to use the A, though, as a guide point that goes up and down from the baseline. I'm going to show you how this works. Trust me. Now, these guys right here, these dashed lines, very good. These are called asymptotes. Asymptotes, I don't know if you guys remember or not, from Algebra 1 and 2, asymptotes are boundaries. They're kind of like, you know, you guys watch movies and stuff. Think of it as an invisible force field, literally, because it is invisible. It is an invisible force field that contains the tangent graph within it. The tangent graph, as you can see, gets very, 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 very close to the asymptote, but will never cross the asymptote. That's not going to happen. That little straight line that I just drew there, that will not happen. If that happens, you messed up. Okay? The tangent's going to just get real close to the asymptote and then close to the asymptote, but it will never, ever touch or cross the asymptote. When you figure out your asymptotes, what you're going to have here, guys, is two things. When you find your asymptote, on this side, you're going to find your starting point. That's your starting point. That's your first asymptote, okay? So you can call it the first asymptote, or the first point, or the starting point. This guy over here is going to be your end point, or your ending asymptote. This is very important. This is where books have messed me up for years, in addition to my students. Once you have the starting and ending point, now you can find your period. Your period is going to be the end point minus the starting point. That is an absolute value. It will be a positive. The period is a distance, so it is a positive. Okay? Once you have your period, you divide that by 4, just like we've done before, and you find your intervals. Go ahead and write this down, please. And then I'm going to show you step by step what to do. We're going to graph it. Then we're going to do a practice graph. And then we'll see if we have time for another one. So this is not that bad if you follow the procedures. Not that bad. Yes, sir. The starting point will always be negative. Not necessarily. Not necessarily. No, sir. You could have a starting point far to the right. You could. Not necessarily. In our purposes, for now, for today, without any shifts, yes. All right. Does that make sense? Okay. Let us continue. Now, let's see how we do this. I got y equals -3 excuse me, times the tangent of 1/2 x. Yes. No, let's first go through it real quick and then I'll let you. Thank you, sir. So, first thing I want to do is check out my asymptote. What is my asymptote going to be? Well, I'll split screen it just in case. My asymptote, if you remember, it's b times x minus d equals pi over 2 or negative pi over 2. Now, in this particular case, I don't have a minus d, do I? In this particular case right here, this is just 1/2 of x. I don't have a minus d, do I? My minus d is 0, correct? So we don't have to worry about that. So that's why I just put here the 1/2 x equals negative pi over 2 or pi over 2. For those of you that don't like radians, I am letting you know radians are going to be part of your life. But for now, if you want to translate it into degrees, that's fine. And you're going to have 1/2 of x equals negative 90 or 90. So when you go ahead and solve for this, guys, and you multiply 2 to both sides, to all sides actually, you're going to get my asymptotes are negative pi and pi. Or, if you go ahead and multiply 2 over here in the numbers in the actual degrees, you'll have that x is between negative 180 and positive 180. Is everyone with me so far? Promise? Yes? Yes, sir. Because pi over 2 is 90, sir. Yes, pi over 2 always has to be 90. Yes. Yes, sir. That's why I put this formula right here for you, sir. This formula is never going to change. The period of a tangent, okay, the period of a tangent equals 180 degrees. So that is why you have to put for both plus and minus 180. Does that make sense, son? Yes, sir?
So the graph will never pass the asymptote, but can it be on it?
No. Third time I've said this. The tangent graph will never be on or past the asymptote. Ever. Thank you, sir. Now, let's find our period. Our period is the endpoint minus the starting point. Well, my endpoint is pi, right? Or 90. Wait a second. What did I just do here? This is wrong here. My bad. My bad. And no, it's not pi over 2. We just found the asymptotes right here. The starting points and the endpoints. Where I messed up was, and I apologize greatly, that's 180. That's 180. Maybe I should pay attention. That's 360. And that's 360. Don't be like Mr. Morrow. Pay attention. I apologize greatly. There's no excuse for that. Sorry. So, like I said, it's endpoint, which is pi, or 180, minus my starting point, which is negative pi, or negative 180. Pi minus a negative pi is 2 pi. Absolute value of 2 pi is 2 pi. 180 minus a negative 180 is absolute value of 360. Absolute value of 360 is 360. Boom. That's my period. Hence my period. Number 3, interval is my period, which is 2 pi divided by 4. How did I get to 90? Well, 360 divided by 4 gives me 90 degrees. Is everyone with me so far? Okay, now, let me show you how to graph this. Because it's easy, easy, easy. Actually, you know what? I'm going to keep it on split screen so we can see all the actual values. Okay. So, even though I don't have an amplitude, I have a guiding point here. My A is 3, right? It's negative 3, first of all. So we're going to have a negative graph here. But it's 3. So I go up to 3, and I go down to 3. Because that's going to be my guiding point. Next, my asymptotes. I'm going to label my asymptotes. I got an asymptote here at negative pi, which is negative 180. And I've got another asymptote at pi, which is 180 for my asymptote. Now, I know that my period is 360 degrees because I figured that out. Okay. My intervals are 90 because period divided by 4 is 90. So, negative 180 plus 90 would give me negative pi over 2 or negative 90. Plus 90, I'm at the 0 point. Plus 90, I'm at the pi over 2, which is 90 degrees. And then plus my last 90, I get back to my asymptote. Is everyone with me so far? You promise? Okay, now, check this out. I'm sorry, I should have done this before. When you have a positive tangent, and again, I do apologize. When you have a positive tangent, here's my asymptote, here's my asymptote. I'm going to go from bottom left to right, going up for positive. For negative, which is what we're going to graph right now, y equals negative a times the tangent of x. You have your asymptote, you have your asymptote. But instead of going from left to right increasing, I'm going from left to right, bless you, decreasing. Sorry, I should have done that before. I apologize. Bless you. Does that make sense, boys? So, okay, so now watch. Put your pencils down and pay attention. There's no rhythm like baseline peak, baseline trough, baseline. There's no rhythm for this. So I kind of made up my own rhythm, okay? From your asymptote, you can't touch the asymptote, so you're not going to have a point on the asymptote. But at my first interval, which is right here at negative 90, match that up with the 3, with the A. That's your guiding point. Okay? Then you're going to have the center, which is between the first interval and your asymptote right here. Then 90 to the right, you go down to your guiding point again. And now you curve it to the best of your ability. I'm not looking for Picasso, but I do not want this either. Oh, Moro, I thought it was a straight line. I will not accept that. I'm going to be fair. I don't need it perfect like it came from a graphing calculator, but it is not a straight line. Yes, sir. Tangent could be any number. I don't know what that means. No, I didn't say it can be. The value of tangent can be anything. Yeah, that's why I keep going up and down. It has boundaries because the x values have... Okay, what's the tangent of 180, if you guys remember? Sine over cosine. Oh, no, I'm sorry, that's 0. What's the tangent of 270? No, 180. Cosine over sine, sine over cosine, tangent. No, yeah, that'd be 0. What is a tangent 270? Undefined. So you can't have a value there for undefined. Asymptotes are boundaries where when you plug in those values, you're going to have an undefined tangent. You cannot have values there. Okay? Now let's walk through another one. This time, let's complicate it just a little bit. I had planned on putting the graph there, so this isn't really going to help us too much. We'll skip that page. This I had done. We've already done it, but I just put another page just to make sure you have them all nice and neat. Positive sine graph, negative sine graph, positive cosine graph, negative cosine graph, positive tangent graph, negative tangent graph. Okay, you already have all of that. Now, last but not least, let's get rid of this. Okay. We got y equals 2 times the tangent of x plus pi over 4. What? Easy. My asymptotes. Basically, all of this, you set it equal to negative pi over 2 or pi over 2. Or if you want to go in degrees, negative 90 to 90, but you better make sure you turn pi over 4 into 45 degrees. If you're going to go through the degrees. You with me? Yes? Okay, so let's find the intervals here. I'm going to subtract pi over 4 to both sides. And this is why a lot of people don't like using radians, because with all due respect, they forget how it is to go ahead and add fractions. So this is going to be negative 3 pi over 4. This is going to be pi over 4. If you do it by degrees, you subtract 45 to both sides. So x is going to equal negative 135 and 45. These are my asymptotes. Okay, these are my asymptotes. My period is going to be my end point minus my starting point. My end point is, what is wrong with me today? It's not pi over 2, stupid. I apologize completely. My degrees are perfect. These are less than perfect. And I apologize greatly for that. We've got it between and negative 3 pi over 4. Wow, that was an epic fail. And I apologize. No excuses for that. Okay. So, I've got pi over 4 minus a negative 3 pi over 4. So that's pi over 4 plus pi over 4, which is 4 pi over 4, which is pi. or 45 minus a negative 135, that's 180. Feel me? Now, let's graph this sucker. Okay. Let's go ahead and graph this bad boy. Okay, first thing I'm going to do is I'm going to graph my asymptotes. My asymptotes are between negative 135 and 45. So negative 135, and let's put here 45. These are my asymptotes. If I'm doing them by radians, this is 3 pi over 4, and this is pi over 4. We know my period, okay? And now we got to do my intervals. What would my intervals be? My intervals, Mr. Morrow, are the period divided by 4. The period here is pi divided by 4, or 180 divided by 4. So my period is 45 degrees, or pi over 4. So I move over 45 degrees, that takes me to negative 90. 45 degrees, that takes me to negative 45. 45 degrees takes me to 0, and then 45 is my asymptote. Come again, son? Yes, it is a negative 45. You with me? Okay, so now, my amplitude was 2, negative 2. It's positive this time. So at my first interval, it's at my amplitude guide point. My second interval is always on the baseline. You with me, guys? Then my third interval is right there. And this is going to be like that. And I got to go through that point, but there it is. Does that make sense? Yes, sir. Come again? Come again, son? You totally messing me up there, man. No, look. Your first interval is right here at your guide point. Second interval of 45 is on the baseline. Third interval on your guide point again. And the next interval is your asymptote. So this goes up like this to the best of your ability. But it's not a straight line. Now, listen up. Your homework is valid for the 4-1. But I will tell you right now, they don't have any tangent questions on the homework. So tomorrow, I will definitely go over some tangent questions in the morning. But definitely practice the tangent, okay? You can find tangent problems to practice in 4-3. Have a great day. God bless you all. Thank you.